Hey guys, welcome back to another tutorial on creating the game of Tetris from within Minecraft. And in this tutorial, we're going to actually start digging into a little bit of harder algorithms. So far we've done those like lookup tables to look up the locations for all the different kinds of blocks, which is a lot of grind work. And I find the harder algorithms and evaluation patterns a little bit more fun. So we're going to start to get into that now. And we'll start with this moveIsClear function. Basically, how to programmatically answer the question, is it okay if we move this block left? Yes or no? Is it okay if we move this block right? Yes or no? Okay, so we'll start with that one and then we'll move on to the is rotation clear one after. It's a little bit harder to do the is rotation clear. All right, so let's go over it visually first, and then we'll move on to showing you the output and then the code, and then you guys can try to code it yourself. All right, so let's pretend this is our cursor drone. This is our little sort of frame of reference, block frame of reference, and this is our left side down I block. All right, so let's pretend as well that we want to see if the I block can be moved to the left direction. So we need to test and see if a left direction movement is okay. Okay, so the first thing that we need to do is we need to move temporarily our frame of reference left. Our cursor drone, basically, we need to temporarily move them left. And then we need to call the getLocations function that we've already written to get all the 4 new locations of this block, whatever block it is. And it needs to be flexible. It needs to work with any block. So we call the getLocations function, and then it returns some 4 locations, whether it's this I block or a different block. And then the next thing that we're going to do is we're going to evaluate the material at each of those locations one at a time and see, is the material made of air or the material of the current block? If it is, then check the next block, the next location. If it's not, you need to return false. And if you can get through all 4 of the new locations without reaching a block that is either not air or not the material that the block is made of, in this case diamond, then it needs to return true, meaning we haven't run into, basically programmatically saying, we haven't run into any diamond blocks, or sorry, we haven't run into any blocks that are not diamond or are not air. So we can move that block left, right? And this is kind of, you can probably see now a little bit better why it's important that it's okay to return true if it's all diamond block. Because, well, if in this case you move left, we're trying to move left, then these 3 blocks right here are going to be diamond blocks. And in this case, it actually should be okay. If you've ever played Tetris, it should be okay to move left in this case. If this is like air, it should be okay to move left in this case. So it needs to be okay for a block to collide with itself in terms of when you're moving a block or rotating a block. Okay, so let's go ahead and I'll show you the output here. All right, so here's my function right here, and we'll run it right here. So basically when we run it right here in a left side down orientation, it needs to scan, it needs to move the cursor drone right here, and then it needs to scan these 4 blocks, this cobblestone, this diamond, and this air. It needs to scan all of these. And if the first time it runs into anything that's not diamond or air, it needs to return false. So you could probably guess what's going to happen in this case. It's going to run into this cobblestone and return false immediately. So let's check that out. Cool. So it ran into the cobblestone, and I have it set to output the type of material that it is as it's running into them. So it runs into cobblestone, returns false. All right, let's try it here. So this should run into diamond, that's okay. Diamond, that's okay. Air, that's okay. Cobblestone, false. All right, cool. All right, let's try one that's actually okay. So we could try this one right here. Cool, so you see now my output is moveIsClear. That's good. You try it here. Cool, diamond, diamond, air, air, good. moveIsClear. Okay, so that's shows you the output, and actually the process that I go through when I'm testing these things, getting the habit of testing these different cases and actually writing these functions in a way that allows you to test it like this is really important. All right, so here's the code. First thing I want to show you is this new enum with directions. All right, directions right here, left, right, and down. Okay. Okay, so in this little test main function, we have our cursor drone that gets passed into the moveIsClear. Obviously, that's important because that's like the current block's location is stored within that. And then we have our direction, which is left that I was running, block type, and then blocks orientation. The blocks type and blocks orientation, those are going to get passed into the get locations function so that we know, we need to know which locations to get based on the types of block it is and the orientation of it, as well as the get material function that we have already gone over. All right, so and you can see if moveIsClear, you can call it in a really high level language way as you're reading this code. It says if moveIsClear, then send the message moveIsClear. All right, so go ahead and I'll challenge you guys to see if you guys can code it yourself, and then when we come back, I'll show you guys the actual code.